Okay, we'll start. Uh, my name is Sumit Sagar Hota. Okay, my name is Sumit Sagar Hota. I am a PMRA PhD scholar IIT Palakkad, and today we will discuss week 7 of the live discussion section, in which lecture 31 to lecture 35 is covered by Professor Asakdev sir, IIT Kanpur, of the subject Introduction to Airbreathing and Propulsion by NPTEL. Okay. The prerequisite for this section is you have to watch lecture 31 to lecture 35 of the week 7. Okay, the first question. In a turboprop engine, the expansion of gas takes place partly in dash and partly in dash. Okay. The answer is turboprop engine okay, there are two parts, one is turbine, one is nozzle. Okay, so one part is there in turbine and another part will be in nozzle in a turboprop engine. Okay. Okay. Next is dash percentage expansion takes place in the turbine and dash percent expansion takes place in the nozzle of a turboprop engine. Okay. Okay, in turbine how much percent expansion and in nozzle how many percentage expansion. Okay, so in turbine of a turboprop engine. Okay, so 80% expansion in turbine and 20% expansion in nozzle. Okay, so this is the answer and this is the answer, 80 and 20. Okay, next question. The turboprop engine can operate economically over a wide range of speed. Is it true or false? Okay, so yes, the answer is true. It can operate in wide range of speeds economically. Okay. Okay, next question. The frontal area in turboprop engine is more than in propeller engines, so the drag is reduced. Is it a false or true statement? Okay. The answer is B, which is false. Okay. Let AF is the frontal area of turboprop engine. It is always less than the frontal area of the propeller engine. Okay, that's the reason it is false. What is AF? Frontal area. Okay. In a turboprop engine at high speed, the propeller efficiency what decreases, increases, what it will be. Okay. The answer is B. It decreases. Because of air drag. Okay. So answer is B. Then next question. Reduction gear exists in a turboprop engine. True or false? Okay. So obviously it's truth. Reduction gears are exist. Okay. Okay. The reduction gear exists in turboprop engine. Okay. Then reduction gear in a turboprop engine dash the cost and consumes certain energy. So reduction gear means one extra part, okay, in the turboprop engine. If there is one extra component is there, that means it will obviously increase the what cost. The turboprop engine are widely used in where? Okay, it is both used in commercial aircrafts and military aircrafts. Okay, so the answer is A. Sorry, C. Okay, both A and B. Okay. These are what applications. Okay, applications of turboprop engine. Okay. 9. Turboprop engine is very flexible and having good fuel economy. Okay. Yes, obviously the answer is what? True. Okay, so next question. The flight speed of turboprop engine is what? Okay, so always remember the flight speed never be somewhat 600, more than 600 in turboprop engine. Okay, it's not having very high flight speed. Okay, so 600 means there will be two options. Maybe A will be the option or D will be the option. Okay, 200 to 400 is not also the range. Okay, maybe Ramjet will be lying this side. Okay, somewhat more advanced. So the option is what? 400 to 600. Okay, the option A. Okay, flight speed of turboprop engine is 400 to 600 km per hour. Okay. The Rolls-Royce developed the AE2100, okay, based on the T56 but with a free power turbine with an output of dash kilowatt, and this was used in the C-130J and C-27 military transports. Okay, so these questions are somewhat theoretical questions. Okay, so these kinds of some special questions are there. Okay, these questions you should remember. Okay, so this kind of questions are also expected in your exams. Okay, if you know, then you can answer, otherwise you can't answer, just leave it. Okay, so okay, for example, if you don't know anything, okay, what is the option and how you should approach this question. Okay, so the first one thing you should see one very good hint you can see, free power turbine. Okay, it's a turbine, that means turbo based jet. Okay, second hint is that military transport. So very few options are there where military transports are used. Okay, so most of the cases when you see military transports are there, that means you just assume it as what? Turboprop. Okay, military transport means turboprop, that's it. Okay, so maybe turboprop is there, maybe turbo if because it's a free power turbine is there. Okay, that means it can be a turboprop or it can be a what? Turbo shaft, but it's there writing that you see C-130J. Okay, Rolls-Royce developed AE2100 then T56 with a free power turbine. Okay, free power turbine means you only turbine. Okay, free power turbine means it's obviously turboprop, not turbo shaft. Okay, so so this there is, from this two hint we know that turboprop. Okay, now turboprop, what is the power requirement, output power? Okay, that you should know. Okay, so turbo, okay, that also if you don't know. Okay, always remember the power cannot be whatever the engine it will be, the power cannot be this much, least 500, so this cannot be the option, and the power cannot be 10,000. Okay, this much power if it is required, then there is no use of this machine. Okay, so obviously these two options directly you cancel. Okay, so there will be two options, one is 2500 and one is 4500. Okay, so in between two options we have to choose one. Okay, so if you are so that's the reason these two options are also given. Okay, so the actual answer is what? C. Okay, if you really know, then only you can answer. These two you can remove, but this in between these two you may confuse. Okay, so like that, if you are also don't know anything, also you can approach this question like this. Okay, okay, so the answer is C. Output power. Okay, the next question: the turboshaft engine in which the output power drives a dash. Okay, this is very good question. There will be no options in this kind of questions. When there is no options, then there is these questions are more common questions or more important questions. Okay, or mainly significant criteria of a any kind of engine. Then this kind of questions are there if there is no options. Okay, if it is not MCQ. Okay, then you have to take care of words, spellings, everything. Okay, to answer this kind of question. So there is always two things you always remember. If there is in the question turbo shaft mentioned, okay, turbo shaft means always what? Helicopter. Okay, there is no other any other place turbo shaft is used. Okay, turbo shaft always used in helicopters. Okay, next question: the helicopter speeds are limited to about dash knots. Okay, the answer, this is very tricky question. Okay, so if you know the answer, then you can answer, then otherwise you can't answer this question. Okay, because these options are very what? Nearer. Okay, if you okay, so always remember, if you know helicopter is there na, the velocity always lie in between what? Nearly near to what? 100. Okay, 150 nearly. Okay, nearly, maybe it will be 150 to maybe 170. Okay, okay, this much knots will be the velocity. Okay, but here in the options, okay, so nearly you know 150, near 150 the answer, so what exact will be 160. Okay, so for this question answer is B. Okay, okay, the Rolls-Royce 250 and PWC 200 turboshaft uses a dash. Remember always, whatever these options, Rolls-Royce, PWC 200, all these things are given in your question to what? To keep you confused. Okay, you begin we don't know what is Rolls-Royce 250, what is PWC 200, then you are gone. Okay, so always remember in this question what we need. Okay, we need turboshaft. Okay, this is the only thing in the question required. Okay, That's it. That means in the question it's asked for the turbo shaft. Okay, what is the kind of compressor it's used? Always remember, for any kind of turbo shaft engine, centrifugal compressors are used. Okay. So the answer is A. Turbo shaft centrifugal compressor. And what is the exact thing in the question? Rolls Royce 250 and PWC 200. Okay. Okay, answer is A. Next question. So now Rolls Royce 250 PWC 200 turbo shaft limiting the cycle pressure ratio or 2 over what? Again, I already told you there is no role of all this thing. Only turbo shaft. What is the cycle pressure ratio? Okay. So always remember for the turbo shaft engine the pressure ratio always near to 10. Okay. It cannot be 15. It cannot be near to 20. It cannot be as much less as 5. Okay. So the near 10 option is 9. Okay. So answer is what? Here 9. Okay. T800 jointly developed by Rolls Royce and Honeywell turbo shaft uses what? Okay. Okay, turbo shaft is there. Okay, in this question, okay, the T800. Okay, I just write down here also what is the type of turbo shaft. Turbo shaft we know always uses centrifugal compressor. Okay, but what is the stages of the centrifugal compressor? Whatever. So always remember odd number is not the possible. Okay, whatever the odd number directly remove. Okay, if there is a centrifugal compressor and there is staging, there will be always even number of staging, not a odd number. So single gone, 3 gone, 1 3 gone. So option is A. That's it. If you know also what is centrifugal compressor, what is the staging, you can answer. You don't know, no need to know what is about turbo shaft. Okay. So answer is A. Turbo shaft. Two-stage centrifugal compressor. Turbo shaft. What is the type? T800. Whatever the type, it does not matter. Okay. T800 Rolls Royce and Honeywell. Okay. Now we will go for one problem. A jet propelled plane consuming air at a rate of 18.2 kg per second is to fly at Mach number of 0.6 at an altitude of 45 meter. PA at the 4500 meter. What is the properties of pressure and temperature is given? That is, it is air, so 0.55 bar, and TA 255 Kelvin. The diffuser, which has a pressure coefficient of 0.9, decreases the flow to a negligible velocity. The compressor pressure ratio is 5 and the maximum temperature in the combustion chamber is 1273 Kelvin. After expanding in the turbine, the gases continue to expand in the nozzle to a pressure of 0.69 bar. The isentropic efficiency of compressor is 0.81 and of turbine is 0.85 and of a nozzle is 0.915. The heating value of the fuel is 45870 kJ per kg, assuming Cp equal to 1.005 kJ per kg Kelvin, Cpg 1.147 kJ per kg Kelvin, gamma of air 1.4 and gamma of gas is 1.33. Okay. Power, calculate power input to the compressor, power output of turbine, the fuel air ratio, the thrust provided by the engine, the thrust power developed. Okay. So this is a long question. So here you see 5 parts are there and 5 individual parts can be your short question. Okay. So means in 5 also nearly 8 or 9, nearly 10 question you will get. Okay. Directly we are solving nearly 8 to 9 minimum or maximum 10 questions. Okay. In this one question. Okay. Because in your exam some short question will come. Okay. Like that, like this, some values will be there. Okay. And not necessarily this much all the values should be given maybe the question can be reduced to 10% of the whole question and then they will ask you the question. So like that in the questions will be so that this is I always take the long question. Okay, in the next classes also like that I will take the long question there. I will cover that question so that all the questions similar to that will be automatically clear. Okay, so that's what the idea. Okay, so let's start this question. Okay, we'll slowly proceed this question. Okay, up to 8 o'clock. Okay. So okay, in this kind of question, what is your first task? First task is to draw the cycle. This is your ambient. So this point is your 1 dash, this point is your 1, this point is your 2 dash, this is your 2, this is your 3, this is 4, this is 4 dash, this is your 5 dash, this is 5. Okay, so yes, everything I think named, and this is your ambient. Okay, so now our graph is ready. So let's go to the solution. So what is the NC efficiency of the compressor, isentropic efficiency of the compressor? It is what? 0.81. Isentropic efficiency of the turbine 0.85. Okay, and isentropic efficiency of the nozzle is equal to 0.915. Okay, actually these values are given here. Okay, see, compressor 0.81, turbine 0.85, nozzle 0.915. Okay, so I just substitute everything here. Now what is the formula for T1 dash? Okay, that we already know. What is the formula of T1 dash? So now this can be I told you na, there is lots of question we can take. So T1 dash, one can be one question, which is TA plus BI square divided by 2CP. Okay, so this is what the formula of T1 dash. Okay, many things we don't know. So then we go for Mach number. What is Mach number? M equal to 0.6. See, it's mentioned Mach number 0.6. Okay, okay, so what we can do? What is Mach number? BI what is Mach number's formula? Actual velocity by sonic velocity. So actual velocity BI, sonic velocity formula gamma RTD, gamma RTD. Okay, okay, what is the unknown? BI is the unknown. Okay, BI divided by gamma. What is gamma? 1.4. What is R? For air in joule per kg Kelvin, it is 287. Temperature, what is the temperature? 255 Kelvin. Okay, where is 255 came? Okay, you see it's in the written, and in the altitude of 4500 meter, PA 0.55 bar and TA 25 Kelvin to 55 Kelvin. Okay, so that's the reason why this TA came into existence. Okay, just write down TA. Okay, now the substitute, because here left side 0.6 given, right side only denominator given. Now you can easily find out what VI. Okay, so when you calculate VI, you get VI as what? 192.06 meter per second. Okay, so why I calculate this VI now you understand, because in the previous formula of T1 dash, TA is given, only VI is not given, CP is also given. Okay, so that's the reason why I just calculated VI. So now you can substitute in this and find out the T1 dash. Okay, so TA is your 255. I already show you. Velocity now you just calculated, divided by 2 into 1.005. Okay, so now T1 dash comes out to be 273.35 Kelvin. Now you got your T1 dash. Okay, so now in the question, one very good thing mentioned: diffuser coefficient, ramming efficiency. Okay, so here directly not written ramming. Okay, so you can write down diffuser coefficient, ramming efficiency. Okay, so where this thing came, see it's written the diffuser with has a pressure coefficient of 0.9. Okay, so what is your ramming efficiency? Diffuser having any efficiency means what does it mean? That means it's ramming. Okay, if diffuser having any efficiency in the question mentioned, that means it's ramming. Okay, what is the formula of ramming efficiency? P1. Ram, where is the diffuser? In between A and 1. Okay, because of ramming, what does it comes out to be? The pressure become P1 to what? P1 dash. Okay, or P1 dash to P1, whatever you can tell, because P1 dash is the isentropic. Okay, so it will be P1 will be actual. Okay, because of ramming it becomes actual. Okay, that means it's from 1 dash to 1. Okay, so P1 minus PA divided by P1 dash minus PA. Okay, now we don't know what is all these things. What is P1 dash? We don't know. Okay, so P1 also you don't know, P1 dash also you don't know. Okay, so we cannot use this formula now. First we have to find out what P1 dash. Okay, so how we find out P1 dash? Okay, we have to apply the temperature pressure relation. Okay, in between A and 1. Okay, so TA to the power gamma PA to the power gamma minus 1 is equal to T1 gamma P1 to the power gamma minus 1. Okay, to directly write down P1 dash. Where is the P1 dash? sorry, this is P1 dash. Okay, so P1 dash is equal to what? Directly I just substitute all these values and put it. All these values you know anyway. Okay, you know PA is your 0.55, TA is your what? 255, T1 is your what? We found out now 273.35. You know everything. Now you just substitute and find out what P1 dash. 273.55 divided by 255 to the power, okay, gamma minus 1 by what? Gamma. Okay, so if you do it, okay, directly the value I am writing 3.5 you will get. Okay, here gamma is what? Gamma is here 1.4. Okay, now if you solve this, you get P1 dash as 0 because all in what? Bar. Okay, 0.5 in bar, so the answer should be in bar. 0.70144 bar. Okay, now you know P1 dash. That means we can now use in, you can put in rhyming efficiency and we can find out what? P1. Okay, because okay, now just directly write down what is rhyming efficiency. 0.1 P1 minus 0.55. This is the formula of rhyming efficiency. N rhyme is equal to 0.9 P1 minus PA divided by P1 dash PA. Only PA we know, P1 dash I know. We just have to find out what? P1. That's it. So P1 minus 0.55, 0.70144 minus 0.55. 0.6863 bar. Okay, so this is the answer. You get P1. Okay, now we have to move to what? 1 to 2 dash. Okay, now what is the next part? Next part is the what? Compression 1 to 2. Okay, so if there is compression in 1 to 2, then what efficiency will come? Compression efficiency. Okay, so what is compression efficiency formula? What is the value given? 0.81 is equal to T2 dash minus T1 divided by T2 minus T1. Okay, you know T2? No. You know T2 dash? No. Okay, that means you know T1? Yes. So T2 dash we need to first find out. Again you apply the what? The isentropic relation in what? 1 and 2 dash. Okay, that is what? T2 dash by T2, sorry, T2 dash to the power 1.4, P2 to the power 0.4 is equal to T1 to the power 1.4, P1 to the power 0.4. Okay, what is P2 by P1 given? Because in the question it's mentioned. What it's mentioned? Where is mentioned? Yeah, the compressor pressure ratio is 5. Okay, so P2 by P1 is equal to P2 by P1 is equal to what? 5. Okay, so and what is your T1? T1 is your 273.35. Okay, so substitute and find out T2 dash. What is T2 dash? T2 dash is equal to 273.35 into 5 to the power 2 by 7. Okay, so 2 by 7 is just means gamma minus 1, all these things. Okay, when you do, you just find out. So T2 dash is equal to 432.94 Kelvin. Okay, so this is your T2 dash. Now if you are T2 dash, then put it in what? Here, isentropic efficiency, and find out what? T2. Okay, so what is T2? T2 is equal to T1 plus T2 dash minus T1 divided by 0.81, which is your isentropic efficiency, sorry, compressor efficiency. So T1 is your 273.35, T2 minus T1, T2 dash minus T1. Okay, 432.94 minus T1. What is T1? Okay, T1 is your 273.55, sorry, 35. If you do 159.273.35. Okay, if you do, it will be 159.59, 0.81. So when you solve it, you get your T2 as 470.3, sorry, 470.3. Okay, directly write down 470.4 Kelvin. Okay, so now what is the work done by the or power input to the what? Compressor. Because in the question first bit it asked what is the, what is it, where is it? Yes, you see, what is the power input to the compressor. So we have all the values, we can directly calculate the power input to the compressor. Okay, let it be WC dot is equal to M dot Cp T2 minus T1. Okay, Okay, what is m dot, what is Cp, m dot, where is m dot? Okay, where is m dot? M dot is here what? The jet propelled plane is consuming air at a rate of 18.2 kg per second, which is your m dot. Cp 1.005. Okay. M dot 18.2, Cp 1.005, T2 470.4, T1 273.35. Okay. And if you calculate, you get 3603.713 kilowatt. Okay. 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 So we now know the what power input to the compressor. Okay, we just calculated here what we just have. You see in the question we have isentropic efficiency of the compressor, turbine and nozzle. Okay, we calculated it. This is the cycle for a turboprop engine. T1 dash, this is the formula. Okay, here vi we don't know. Okay, we just substitute here in this formula of Mach number because we know. Okay, so we find out vi, then we find out vi, put it in the what T1 dash formula. Okay, then T1 dash formula we just substitute, then we just find out T1 dash. We know ramming efficiency 0.9. What is the formula? P1 minus PA divided by P1 dash minus PA. Okay, so put in, then how to find out this P1 dash? You have to apply in A to 1 dash in A to 1 cycle this formula. Okay, temperature and pressure ratio formula. Find out P1 dash, put it in the ramming efficiency formula, find out P1. Okay, so then you put in the compressor efficiency 0.81. You have apply the temperature pressure formula. Okay, find out T2 dash, substitute in the compressor efficiency, isentropic efficiency of the compressor, find out the T2. Okay, so again E2 T2 you find out. Okay, now substitute in your formula of the what power input to the compressor. Okay, which is 3603.713 kilowatt. Okay, now one part is now over. Okay. Okay, so next is your what? Fuel air ratio. Okay. Okay. Now let's go. Now what is heat addition? Okay, now we go for the heat addition. Okay, so you see, I can show you here what ramming. Here WC. Okay, here WT. Here it will be confusing. One more. Here nozzle. Okay, here heat addition, here heat rejection. Okay, that means 2 to 3 heat addition, and 5 to A is your heat rejection. Okay, so write down the heat addition formula. Ma1 plus F, okay, into CPZ T3 minus MACP T2 MAF into CV into combustion efficiency. Okay, this is the formula you have to remember. Okay, CPG means CP of gas and CP only written means in CP of air. Okay, CP means calorific value. Okay, here we have to find out the small f. Okay, for airfield ratio small f we need to find out. Okay, so small f is our next requirement. Okay, second bit is your what? The fuel air ratio. It's in the written in the question. Where is it? Yes. What is the second question? So the second question is power output of turbine. Then your fuel air ratio. Third question. Okay. Okay, so that's the reason like this small f is written, very small f. Okay, small f is your fuel air ratio. Okay, so substitute all these values. Just you see here one thing is common, m dot a. M dot A is found everywhere, cancel m dot A. Then substitute the values. 1 F we don't know, CPG 1.147, T3 1273, CP of air 1.00, CP of air write down, T2 470.4 is equal to F, calorific value 45870. Combustion efficiency not given, that means assume it as what 100%. Okay, okay. Now if you solve all this thing, then you get F as 987. Directly write down the answer. Okay, 0.02223. Okay, this is your what? Fuel air ratio, which is your what? Third bit answer. Okay, so if you know Cp, if you know F, okay, fuel air ratio. What is fuel air ratio means? What is the definition of fuel air ratio? F is equal to what? Mass flow rate of fuel divided by mass flow rate of what? Air, or mass of fuel divided by mass of air. Okay. What we know? We know the mass flow rate of the what? Air, not of the fuel. Okay. So the substitute here, and mf you just find out m dot f, because m dot a is already given. Okay, where is everything given? You see here CPG also given, m dot a 18.2 kg per second given. Okay, 18.2 kg per second. Okay, so also we can find out fuel air ratio. Now we need to find out what? Power output of the what? Turbine. Okay, so for that only we are doing all this thing. Okay, so this we find out. Third bit, m dot f is equal to m dot f is equal to 18.2 into 0.0 triple two 3. M dot f 0.405 kg per second. Okay. So anything else given, I just see. Okay. Okay, what is the turbine? Turbines anything given or not? Okay, we just want to see the heating value of the fuel given. Okay, temperature also given. Okay, so here one thing I think not mentioned. Work done by the what? Turbine. Okay. Okay, so work done by the turbine should be given in the question. Okay. Okay. Okay, I get it. Okay, then okay, in the question they are asking about power output of the turbine. Okay, the power output of the turbine they are asking and only giving T3 temperature. Okay, combustion chamber is 1273 Kelvin. This should give what? T4. Okay. Okay. Because without knowing T4 you cannot find out anything else. Okay, so they are asking about power output of the turbine without giving T4. Okay, so yeah, then one thing we can do, okay, so I just tell you what is the value of T4. T4 you just assume it as 1104.125 Kelvin. This is given. If this is not given, then you cannot find out what? Your power output of the turbine. Okay, it's difficult. So what we do, Okay, so okay, so let's do it. So work done by the turbine is equal to what? MA plus MF, fuel plus air, Cp of gas, T3 minus T4. Okay, is equal to MA 1 plus F, Cp of gas, T3 minus T4. Okay, what is MA? 18.2, 1 plus what is F? 0.02223, CPG 1.147, T3 1273, T4 I already told you 1104.125. Okay, you substitute, you find out the turbine work as 3603.713. Okay, kilojoule per kilowatt. Okay, so now you know the turbine work. Okay, this is your what? Second bit. Okay, so now isentropic efficiency of the turbine is your what is isentropic efficiency of the turbine formula? T3 minus what is isentropic efficiency of the turbine given in the question? What? Where is it? T3 turbine is 0.85. Okay, so T3 minus T4 divided by T3 minus T4 what? Dash. Okay, so without, because you see in this question P3 also not given. Okay, sorry, P3 given but P4 dash also not given. Okay, if we know P4 dash, okay, and then only we can calculate the P in the formula of P3 by P4 dash equal to T3 by T4 dash to the power what? Gamma gamma plus 1 by gamma. Okay, so that formula we can use, but here you see there is nothing we can't use. Okay, so that's the reason they should give the what? T4, otherwise it's difficult to find out. Okay, so just substitute in the formula. Here one unknown is that what is what? T4 dash. Okay, 1273 minus 1104.125 divided by 1273 minus T4 dash. Okay, okay, so now you just substitute and find out T4 dash as 1074.32 Kelvin. Now you find out T4 dash. Okay, substitute in the formula, put the pressure ratio in between what? T3 and T4 dash. Okay, T3 by P3, T3 1.33, P3 0.33, because here what, gas is there. Okay, in the compressor air, in the turbine what, gas. This is the difference you should always remember. Okay, T4 dash 1.33, P4 dash 0.33. Okay, so what you want here, the pressure ratio of the turbine, it's not given. So P3 by P4 dash we want. You see here in this question we don't know the pressure ratio in the turbine. Okay, don't directly use the compression pressure ratio as your turbine pressure ratio, then it will be what, wrong, because you see in the question for confusion they are giving that what is they given, the compressor pressure ratio is 5. Okay, the compressor pressure ratio is given, not your what, turbine pressure ratio. Don't be confused with that. Okay, so P3 by P4 dash is not given in the question, so that's the reason what you do, T3 by T4 dash you do. Okay, to the power what, 1.33 by 0.33. sorry, that formula is what, gamma by gamma minus 1, T3 T3 to the power what, gamma, P2 to the power gamma minus 1. Okay, and gamma is your what, gamma of the gas is what, 1.33, it's given. Okay, so if you do this, okay, what you know here, T3 you know 1273, I think, yes, 1273, and what is your T4 dash, (1074.32). Okay, (1273 Kelvin), 1074.32. Okay, if you substitute these values, you get P3 by P4 is equal to RT is equal to pressure ratio in the turbine is equal to 1.98. Okay, so now you know the pressure ratio in the turbine. If you know the pressure ratio in the turbine, then what you want, now you have to go for what, P4, because one thing you also know is that your P3. Okay, where is P3? Okay, where is P3 we need to know. Okay, because you know P2 equal to P3, yes or no, P2 equal, in the plot you can see P2 equal to P3 and P5 equal to what, PA. Okay, so P2 equal to P3, that means in the formula of compression ratio we know what is P2 and P3. What is P2 you know. Okay, sorry, we know at least P1, at least we know. Okay, just need to, okay, P1 is what, 0.6863. okay, okay, so you see in this formula P2 by P1 equal to 5, and what is P2 is equal to what, P3. That means what is P1, 0.6863. that means what is P2 equal to 5 into 0.6863. and what is P2 equal to what, P3. If P2 equal to P3, then what is the value, P3 is equal to 5 into 0.6863. where is this 0.6863 came, here you see written P1 equal to 0.6863. okay, so what is the value, you can write P4 dash is equal to P3 by RT. I just rearrange. Okay, what is P3? 5 into 0.6863, RT 1.98. Okay, Substitute, find out P4 dash 1.732 bar. Okay, so you know P4 dash now. Okay, if you know P4 dash, that means you can now find out in what? Nozzle. Okay, what is nozzle? What is the pressure ratio in nozzle? This can be one question also. Okay, directly not mentioned, but this can be one what? Your question. P4 dash divided by PA. What is the value? 1.732, and what is PA? 0.5. What is the value? 3.1486. Okay. So now, what is the critical pressure ratio? What is critical pressure ratio? P4 by PC. Okay. Where is P4 and where is PC? That's been first C. See, here is the P4 and here is the PC. Okay. In C mean your maybe P5. Okay. So okay, C may be critical. Okay, critical pressure. PC means critical. Okay, I don't mention where is exactly it. Okay, so we have all the datas. One very good big formula is there. Directly they will ask you what is critical pressure ratio. Okay, if you remember the formula, then only can answer, otherwise you can't answer the question. 1 minus gamma minus 1 efficiency of the nozzle into gamma plus 1 to the power gamma by gamma minus 1. Okay, this is the formula. Okay, what is efficiency of the nozzle? 0.915, and what is gamma? 1.33. Okay, substitute, then you get the value as 1.97. Okay, so now you have P4, you know. Yes, you know P4. Why you know P4? Because P4 equal to P4 dash. Okay, how you know? I know P4 equal to P4 dash. You see, same pressure. P4 and P4 dash are same pressure. Okay, so is equal to P4. Okay, so now what you do? PC you find out critical pressure. Okay, what is critical pressure? P4 divided by 1.97. Just rearrange. Okay, if you rearrange here, this P4 you know 1.732, this is your 1.97. Okay, then what is your PC? PC is equal to 0.8794 bar. Okay, correct. Okay, so this is your critical pressure. This can be a very good question. What is critical pressure and temperature? They can ask you, although it's not mentioned in the question what is critical pressure and temperature, but they can ask you very easily. TC, what is the formula for critical temperature? 2 by gamma plus 1 into your what? Nozzle temperature, nozzle inlet temperature, that is what? T4. 2 by 2.33 into T4 1104.125 or turbine exit temperature. Okay, T4 equal to nozzle inlet or turbine exit. So TC will be your next page will write down. TC is equal to 947.75 Kelvin, and this will be your what? Critical temperature. Okay, so critical temperature, you know, that means you can now find out what? Velocity of jet. Square root of gamma r TC. Okay, what is gamma? 1.33. What is r? For gas, not air, don't confuse. Okay, TC we find out 947.75. if you substitute everything, you get as 598.95 meter per second. Okay, so BZ you know. Okay, then what you need to find out? Gamma C, critical density. What is critical density? Just apply ideal gas equation, PC by RTC. What is the critical pressure? We already know, 0.8794 bar. 1 bar how many Pascal? 10 to the power 5 Pascal. R of the gas 287.6. TC, critical temperature 947.75. What is the value? 0.326 kg per meter cube. So what is area of flow? Or the flow area? Okay, or frontal area, whatever you can tell. Okay, we know the formula. What is the total flow rate? MA plus MF is equal to rho C into AN into Vj. Okay, so what is AN now? Substitute all the value. 18.2, 0.405. We already find out the mass flow rate of the what? Fuel, m dot f. Okay, or one way you can write down also. What is this equal to? Ma into 1 plus f. Okay, so 18.2 into 1.0223 divided by rho C 0.326. Okay, then what you want? AN you need to find out. Vj, jet velocity. What is the jet velocity you find out? 598.95. okay, now if you find out what is this, the area of flow, AN is your area of flow. Okay, (0.0953 meter square). Okay, Okay, so now what you do? Now you need to find out the thrust. Last bit is the thrust. Okay, in the question, where is the question? Yes. Thrust and the thrust power. Okay, two bits left. Thrust provided by the engine and the thrust power developed. Okay, these are the things there. Okay, so first is the thrust. Thrust provided by the engine. Okay, what is thrust provided by the engine? F is equal to ma into 1 plus f Vj minus Vi plus an Pc minus Pa. Okay, okay, Vi is your what? At the inlet. Okay, so just apply, substitute all the values. Okay, 18.2, 1.0, 2223, Vj 598.95, 192.06. Okay, and whatever the value is there plus an 0.0953 into PC is your 0.8794 minus 0.55 into 10 to the power 5 to convert it into Pascal. Okay, with the pressure in bar. Okay, if you substitute everything, then you can find out F as 10708.78 Newton. This is the your thrust provided by the engine. Okay, and thrust power, what is your thrust power formula? If you have the force, how to find out the power? Okay, thrust power is your. Okay, so this is your answer of what? This is the answer of fourth bit. Okay, so what is thrust power? P is equal to F into Vi. Okay, what is F? 10708.78, Vi 192.06, 2056.7 kilowatt. Okay, so this is your power. This is your fifth bit answer. Okay, okay, I think with this we can end the section. Okay, if you have any doubt, okay, you can ask me in the comments section in the my YouTube channel. Okay, and you can ask in the question and answer forum of NPTEL. Okay, if you have any doubts. Okay, and we'll meet in the next section. Okay, Saturday 6 to 8 next week. Okay, thank you very much for attending the section.
Thank you, sir.